Come in, everybody. This project will kick off 3 projects that look intensely at issues of sustainability. To kick it off, this is Matthew Doeller.
I think it's slightly afternoon, so good afternoon. As Professor Hurt mentioned, I'm Matthew Doeller. I want to start by thanking my committee, Mr. Vogel, Mr. Hurt,
Matthew, set the standard for talking loud.
Yes, I'm sorry, I have an issue with that, so anybody in the back can't hear me, just kind of give me one of your proposals on that. I'll try to speak up as I start to trail off. So my project today is desert dwelling. I'm sure most of you are aware, you've watched the news at all, of the ongoing drought throughout the western United States. California seems to be featured a lot, as well as the rest of the West. But this really isn't an issue that's just sustained to the United States. In fact, in just 10 years, the United Nations predicts that 2 out of every 3 people will be facing a water shortage. And they're certain that global conflict is going to occur. And the United States really isn't doing much as far as the building culture to address this. We continuously build subdivisions like this one out in Las Vegas in the middle of the desert. And I chose Las Vegas to look at as opposed to California for a few reasons. One is I have a lot of family that lives out there. And 2 is their unique relationship with the reservoir of Lake Mead. Lake Mead is a reservoir behind Hoover Dam. It supplies 90% of Las Vegas' drinking water, as well as providing many recreational opportunities. Kind of taking part of it when visiting families, going boating and things like that. But if I went back today to do that, well, I might have to find a place. As the water level continues to decline because of the drought, has moved that marina. The thought is there's water everywhere. 70% of the earth is water. But of that, a very small percentage of it is actually melted. The rest is salt water, as well as taken up by ice caps, water vapor. All the countries of the world, the United States is the 3rd most consumer of water in the United States, followed only by China. In the United States, almost 42% of that water is used throughout the process of creating electricity throughout the cooling process and things of that nature. And another large portion is consumed by irrigation purposes. If homes only consume about 8%, it doesn't seem like that much. Within that home, though, almost 40% of that water is used by the bathroom fixtures and the toilet. Sorry, everybody. Looking back at the regional scale of Las Vegas, I was surprised to find that almost 45% of the water used is by single-family homes. I expected it to be, the hotels and resorts on the strip. It was very surprising. So further in the research, how are they using this water? We found that 60% of it is actually used for outdoor purposes, for irrigating traditional lawns and garden systems, as well as refilling the pool as it evaporates in the sunlight. And the city is taking steps to reduce this. They actually have one of the most comprehensive water conservation strategies in the country. But it still isn't enough. But one of the strategies that is most effective is by incentivizing xeriscaping, which is essentially removing the grass and replacing with native plants that are drought tolerant, withstand being in the desert without needing irrigation. And as I mentioned, this is having significant benefits. We've seen drastic reductions in that and other legislation to reduce the amount of water. The issue means that although they're ahead of their target goal, it's about 219 gallons per person per day, that's still almost twice the national average, or over twice the national average of 100 gallons per person. This is the problem. One of the things they're not taking advantage of is looking at this connection between water and earth. In order to pump water and supply it, you need energy to do so. In order to create power and to cool the system to do so, you need water. So the 2 are intrinsically linked. This is evident at Lake Mead as it sits behind the Hoover Dam hydroelectric power plant. But as the water level in Lake Mead continues to drop about 2 feet per month, they simply cannot produce power from that water. You can only produce it during peak hours at this point. Which is definitely a drawback is the hydroelectric power doesn't create greenhouse gases or other things that harm the environment. Another issue associated with the water energy is that it takes a considerable amount of energy to pump water. In fact, with the elevations of the cities surrounding Lake Mead, it creates almost 300,000 kilowatt hours to pump the water. In order to ensure the future water supply of surrounding areas, one of the strategies they're taking is to create a lower intake pipe. It seems like a short-term solution to a long-term problem, and it exacerbates this link and connection between the two. On a national level, 40% of our energy is consumed through the creation of electricity. Only a seemingly small percentage by homes and commercial uses. Within those homes, over 40% is for space heating, and another large portion is for appliances and lighting fixtures and electronics. Again, Las Vegas seems to be this anomaly. Almost 25% of the energy use being for single family. I know at this point I've thrown a lot of numbers out there, and you guys are probably glazing over and everything like that. So there's two that I want you to focus on. It's that single family homes consume about 45% of the water use in Las Vegas, and about 25% of the energy. And from that point, that's when I decided that single family homes were going to be the feature of what was going to have the most impact on conserving water energy in the desert environment. Before designing, I looked at what's currently being built. A home like this might be found 2 blocks from here if you put siding on it, something like that. It's restricted to place, and that has no elements that say this is in the desert other than this one. Now, there are some developers who have realized that featuring sustainable aspects help to sell their homes. So there are some developers that are designing homes that use less water and less energy. You're marketing them from the standpoint of monetary savings over the environmental savings. But either way, there's a market for sustainable housing. The issue is that these homes simply don't do enough, and that's where I was stepping in. So desert dwellings are said to be the next standard for development in these arid climates, being as water conservative as possible and being net zero energy. So with that, I've designed 2 homes, a single family or a single story and a multi-story home. It can start to be part of this sustainable community. The single family home is about 1,500 square feet in size. It can be 2 to 3 bedrooms and 2 bathrooms. There's a distinct separation between the public spaces and the private spaces, with the entrance being the mediator. And one of the things that I wanted to focus on was how is water a ritual, a part of this process throughout the home throughout the day. By doing that, feature 2 water tanks right within the entryway. So when you're invited over to your neighbor's cookout or his dinner party, creepily invites you to the door or answers the door, you're immediately addressed with these water tanks that show how much water he's used for the week and how much gray water he's collected and saved. So it puts that aspect of water right in your face from the starting point. So you're aware that this home deals with water and addresses water to some extent. The 2-story home features a more compact footprint on the earth, but it still offers a little bit more square footage. About 1,800 square feet in size, and has an additional bedroom. It can accommodate slightly larger families. It features a double height space over the living and kitchen areas. And on the outdoor space, it has an evaporative cool tower. And what this does is it uses a small amount of water to mist and cool the air. And the cool air then sinks down into the tower and is brought out at a level that is comfortable. It's been shown that these can have the effect of reducing the temperature of the air by up to 10 degrees in the immediate vicinity. So it helps to cool that deck in outdoor space. You might notice that the walls are really thick. In fact, they're 2-foot thick rammed walls that feature a rigid insulation in the center. This was chosen for a few reasons. One, it starts referring back to the vernacular architecture of the desert, which is building with the earth, but it brings it into a modern sense of modern technologies and strategies. It's also aesthetically beautiful, and the sources are locally produced from on-site or within the immediate vicinity. So it reduces the amount of transportation and energy associated with those. Some other sustainable aspects of the home include the roof system, which is structurally insulated panels, provide a high R value and ease of construction. And throughout the home, I really looked at all of the different materials, where they came from, and their aspects of sustainability. For instance, the lumber that's used to support the roof system is by cross-laminated timbers. They come from Quebec. And the reason that was chosen is because they use about 30% more of each tree, as well as the adhesives they're used to combine them are sustainable and environmentally friendly. The home features triple pane windows that come from a manufacturer in Washington State. They feature both casement openings as well as hopper in the same window. So you can have full ventilation when desired. You can also have a hopper feature that allows the ventilation but more security. The rigid insulation in the center of these walls is from recycled glass content, about 98%. So throughout all of the materials, they were really chosen for their durability as well as their sustainability. Kind of got away from the water, didn't we? Maybe we should go back to that. So there's a few strategies for conserving the water. The first and foremost is the fixture systems. Traditional fixtures consume much more water than what I've found. I've found systems that reduce the amount of water considerably. Traditional homes use about 100 gallons per person per day. I can drop that considerably based on simply from the fixtures alone. But in addition to the fixtures, there's the option of reusing water. So the homes feature gray water systems that flush toilets as well as provide the water for the evacuated cool towers. In order to further reduce the amount of water that's coming from the municipality, some of that gray water is pumped to the roof into a water distillation process, which is featured up there. The process mimics that of Mother Nature, the natural environment. By putting a small amount of gray water on the bottom of these stills, they're allowed to heat up in the sun and the water evaporates. It then condenses on the pane of glass, which is cooler, and is collected in a clean, drinkable, distilled water. By doing this, we reduce the amount of water and energy associated with that water to supply the home. Another strategy of reducing the water and energies is by getting to net zero. This was done using a program called BIOP, it's an energy modeling software developed by Enron. And I spent a lot of time working with the form of the house as well as the different parts of it in order to systematically reduce the energy loads associated with it. From increasing the thermal mass to improving the windows, improving the fixtures, the lighting systems, everything like that. And then by adding a 5 kilowatt photovoltaic system to the roof, the homes are actually able to be net zero, or you can produce more energy than they use. With all these strategies in mind, it's really clear that the water use is being reduced. A typical home, as I mentioned, uses about 400 gallons of water. And the sustainable developers have been able to drop that by about 30%, but it still isn't enough. The desert dwelling homes are actually able to reduce the water consumption on a daily basis to about a tenth, about 90% reduction from what they would be. Throughout the course of the year, this results in about 130,000 gallons of water being saved. And based on projected population growth, as well as the average number of people per home. For the next 5 years, they save over 16,000 gallons of water. And in 25 years, they save 271 billion, which is about 410,000 Olympic size swimming pools. So it's clear that by redesigning the home, we can create sustainable communities in the desert, reduce the amount of water and energy needed to do so. And with that, I'd like to open up questions.
Does Lake Mead have any source to replenish it, and either way, how long will it last if we switch to being integrated as a company?
So Lake Mead is primarily filled by the Colorado River. It's mostly replenished from snow on the Colorado Mountains. All the water in Lake Mead, Las Vegas only receives a small portion of it. A lot of it is actually allotted to California, Mexico, the United States, and then nation Mexico. They are predicting that they could run out of water within the next 3 or 4 years. And these savings can obviously drastically reduce the amount of the impacts of that and how fast it will occur. It's tough to tell exactly how much, like percentage-wise, but if I remember the math correctly, it would take, I think the total is 10% of what the entire thing would be throughout that time.
It's, I really appreciate the rigor at the scale of kind of material and systems, and I think what would be helpful is to go back to, I mean, you've started to do it in terms of savings, but to go back to some of your original charts and say, okay, here's how this at the small scale can affect this larger scale. Because I think depending on what kind of results you see, there's still the underlying question of whether building here is appropriate. And so it may help you to think about, do you build this in such a way that it's designed to be moved at some point? Because, you might say, okay, if there's an existing city or set of cities here that are going to last, but I'm anticipating that even given these measures, it's, 30 years from now, we're going to need to repurpose some of these materials somewhere else. Just kind of looping back to that larger scale set of questions.
I agree with that initial thought of should we even build here was one that came up very early on. And I could have said no, and then I wouldn't have a thesis. So what I decided is actually the population has one of the fastest growing in the country, in Nevada. So there's a draw for people to come here. I think mostly for economic reasons. So I'm accepting that people are going to come here, and that in the United States we can't tell them they can't. That would be incredibly difficult to do. It's possible, but difficult. So with that in mind, I move forward with, well, if they are going to live here, what's the most sustainable way that they can do so?
But now we've had this conversation, right? And Gina's offering another way of thinking about it, right? Which is saying, can you make these in a way that perhaps they get moved?
Sure.
And I think, why don't you answer that question?
I think that's a very reasonable suggestion. I think that it would obviously take a very different approach than what I've taken, which is with rammed earth and these heavy materials that are designed to be there for extensive periods of time without any much maintenance or upkeep.
It's just something to think about. Almost, I could imagine almost a kind of phasing set of scenarios that you could start projecting, like, okay, if this is done at this scale, kind of how would the city need to, how would it affect the kind of large scale planning? Or if a certain kind of water tax, I mean, there are a lot of cities that now you pay a certain amount for the size of your trash can and encourages more recycling. So I think what you've set up could operate in a really similar way in terms of letting people know, okay, this is how much I have before I have to start paying an extra fine. And just to think about, okay, how might all of these large-scale issues eventually are going to affect the cost of living in this place. So I think it's worth going back and forth a little bit about how you want to treat that assumption.
I agree. Costs too on a variety of scales kept coming up. Which we don't get much cost estimating in school, but from what I was able to gather, these homes would cost 10 to 15% more initially, but then the reductions of energy as well as water, if that would offset it, as well as incentivize. If the city is already incentivizing people to reduce their water use, I don't see why they wouldn't necessarily incentivize something that's more sustainable.
I have a similar concern to what Gina brings up, in the sense that we find our most sustainable places are our densest cities, because we can build high and other things.
Economies of scale.
It's economies of scale. And I know that, so I was wondering whether or not you had thought about multifamily situations of this to, in a sense, stop the growth and expansion of Las Vegas and begin to concentrate as part of the theory behind this. The other was, so you've achieved not quite net zero, but how could you achieve net zero with water? Because I think it's possible to do that. The other is, there's your cooling tower is used a lot in Saudi Arabia and other places, and it actually produces ice at the bottom of these towers when they get tall enough, that there are passive ways of doing things that, in combination with energy-saving devices and so on, I think are leading towards us being much more conscious about this stuff. My only encouragement was there's a lot of other precedents out there that could have been brought to the investigation from other countries, from a net zero power usage, et cetera, how all of these might be combined to really produce something that's even more sustainable. It begins to question taking a single approach versus a multi-system approach to the problem at hand. But I think in terms of investigating the water issue, I think you can be very comprehensive about that. But just looking at where you place, coming back to the broader question, is just in your orientation studies of the building, obviously, I mean, we've learned that east-west orientation gives us the best and most controllable of environmental situations. But then the xeriscaping, in a sense, almost does a disservice in some respects because it doesn't allow enough of the landscape to be able to provide a lot of the passive qualities that we're trying to do through materials and other kinds of systems. I almost want to build a round earth wall that puts this house into shade, in a sense, to begin to do the same thing the landscape will. And I just encourage you to think a little bit beyond the box of the usual ways of doing things and to really explore as much broader subject, because this is a national issue for us. And I don't think the national issue is in doing more single-family homes. However, doing a single-family home to bring this into either incentives or costs of doing something which is not a good use of resources begins to really make us rethink about how we approach these things and how we are either forced into better practices or encouraged into better practices. I think
it is hard to imagine that the standards will stay the same in a crisis. I mean, this is a crisis. This is a major, major crisis. And yet, I'll still have 2 cars in my car. I'll still have master baths with each suite. And a swimming pool. So, it does kind of I wonder, as you went through this process, at what point did you begin to challenge your assumptions? That we can live so graciously, that we can have air conditioning, that each child needs a full bathroom, So to me, it's a really big issue because I think at the time when the crisis comes, that and only then will you reevaluate what you need. It's hard to imagine reevaluating what you need if you can afford to buy everything. So this person can build a desert house, but the people in the city, in a neighborhood in Baltimore can't, and they're going through the same crisis. So I agree with you that the question of how can we be more sustainable with our cities if we're going to continue to have cities, and when we have given up on the suburban single house attitude of anything can be bought.
I do think it's, one of the other consequences of this is that you think about these crises and the fact that, when it really comes to a head, that there's a kind of moment of, okay, what's the plan? What are we gonna do? And so I think it's really commendable that you're looking at this. And, you know, maybe thinking about how these strategies could apply anywhere. It's this water distillation system that you came up with is really interesting. Have you found that? Did you kind of create that?
I wish I created that.
Yeah.
Actually, it's been used quite extensively
I see.
for many years. The systems that are on the market tend to run about 50% efficient in the summertime, 25% in the wintertime.
Your life goes, your sailboat crash, sinks in the middle of the ocean until you think it's there.
In the life raft,
You get into the
Addressing that kind of issue with the single-family homes was definitely a consideration that I considered early on. Did a single-family home, multifamily, doing both. But because of the high percentage, 45% of the water use being for single-family homes, I thought that was the area of focus because it has the greatest amount to overcome in order to be more sustainable.
Some of those percentages, and I don't know about your sources in particular, but some of the kinds of building sector energy consumption stats that we hear a lot are actually based almost completely on material energy. The energy that's consumed by production and transportation of the material. So it could be that so I think you're addressing that by using the rammed earth and really carefully considering where all of your materials are coming from. But it could be that you could see a kind of similar real impact and still think about the multifamily as the way we go.
It also asks a question. Lee gives points for locality in the sense of procuring materials. You were going across the country to get a lot of numbers to make this work in the sense that because it raises a question, what could be developed locally with the resources that are at hand to see about doing that? I mean, could you take, there's probably double pane windows that are developed here in Las Vegas, or somebody makes them, or it's close by. Could you use double, two windows put together to give you the effect of triple pane windows? Or those kinds of things, taken really off the shelf materials as well to add to this in the process.
At one point, I was thinking about pursuing the Living Building Challenge, the title certifications, and then through that research process, it never came to full fruition. That's why I haven't claimed that it could be what it is. I came across their product database that uses essentially asks manufacturers to include other ingredients and manufacture things like that. And that's actually the source of most of where I get my products. They do, Living Building Challenge also has that idea to do local. They require a certain percentage of materials to do that. And 2,000 miles is about the extent, and only a very small percentage of that can come from there, which in this case was those timbers from Canada.
So your net zero energy claim is, how did you test that to know that that was the case? You could actually say that this would?
Using a energy modeling software.
And that required you to use real products that exist today because they had to be measurable, right?
As well as in my efforts to conserve water and energy, I went seeking for the most energy and water efficient systems. And then the program allows you to add their information to it. So I was able to actually use the appliances and things that I had spec'd out.
I was just surprised that in the two-story system, that there was still enough roof left for the panels, when the panels seemed to fill up a one-story. So I wondered, it's just an aside, you all obviously tested that there is enough roof on these buildings to supply enough solar panel coverage.
Yes. The single-family home features them only on the roof of the public space. and not of the private. And essentially the two-story is the dimensions of the private sector.
Your modular approach almost implies that you wouldn't need laminated big beams. I mean, what's that span?
This span is 24. So it's right at the cusp
Yeah.
of traditional dimensional
Well,
lumber.
we could have had columns
Yeah.
and reduce that issue of the beams being shipped from elsewhere.
The observation about the shade made me think about something that we didn't think about in the course of this, which was basically making someone storing the roof, putting a whole lot of dirt on top and letting the natural desert plants grow up there, and so using the depth of the dirt, plants and stuff to create shade for the whole thing as well as insulation.
Right.
And then, of course, that would have led to, well, what are we going to do with photovoltaic panels? And kind of figuring out something else for them, and or looking at the trade-offs between those two.
Well, it's
Well,
also not covering the whole roof.
They have photovoltaic panels now which are transparent. In fact, I'm investigating for my house, because I want to put them on an outdoor trellis that have vines growing on. And in discussing it with them, if I can get 18 inches or so above that with transparent panels, it will still allow the vegetation to continue, and yet still produce energy.
It's just that you do keep thinking, that finally we're getting to the point where we recognize that the sun might continue to be out there, so
That's
therefore we ought to tap into it for energy. And most of the planet is water. I was thinking that somewhere along the way you were going to tap that big resource, the oceans of salt water that are 95% of the water that exists in the world, to use that as, I mean, when you think on the biggest terms, I guess, that's ultimately going to have to be the challenge, because we've got
Takes a lot of energy.
Yeah, well, we've got lots of energy
Sun.
out there too.
Well, I was also thinking in the sense that there's such a differential change at nighttime to daytime in Las Vegas, and that differential gives you a lot of energy. And how could that be put to use here as well in this process?
Differentiation between
Between
temperature swings?
temperature swings. Because we're able to take heat off of things and use it. We're also able to take coolness off of things and use it in just a normal heat pump system. So how, in a sense, how can we use the natural environment even more so to think creatively about these kinds of conditions? Because I see this, in a sense, what could be learned out of this could be applied to the refugee camp when we looked at yesterday. I'm trying to make the bridge between the two to see, what is there out of here that can be applied to that, and what's out of that can be applied to this project as well.
On the look side of things, it's really important that there be enough insulation there so the inside surface doesn't become hotter than the inside air. If you go back to that refugee situation where you're naturally ventilating, then you don't want, you need enough insulation. That's a very important thing so that this doesn't get overheated.
That's right.
And so you don't need you don't necessarily need a green roof if you stack that thing full of
Well, sure,
insulation.
it's a mass.
Yeah,
It's
the
usually a
green
mass.
roof does reduce the temperature on the outside surface.
What is the typical kind of foundation system? Is it a slab?
Pretty much all slab grade.
Because I think this kind of line of thinking could, the other piece that I was trying to understand is your siting, because you're, and whether or not you can start to think about like how the kind of community or the assembly lays out, because it looks like you tested in a couple of different orientations.
It was kind of being pushed by the committee to get to that community scale and figure out what the development looks like.
Because I think when you do that, you can start to think about what is the collection of cooling towers, what is the collection of slabs, could the air intake happen through a labyrinth that's also a slab, how do these pieces assemble? So that might lead to kind of additional strategies in the collective.
So that's interesting, we're talking about sort of unexplored connections between different components of this thing. At one level, we got a bunch of
That's an
components. The
interesting-
question is, how are we taking advantage of not only the component itself, but potential linkages between the components that have not necessarily been explored. Not just here, but at all.
Yeah.
Interesting.
Well, we're thinking about that when we're thinking about systems integration. In a sense, how can we use local resources? Like we're investigating in Pittsburgh, how can we take heat off the water of the rivers and begin to use it to power, heat and cool 178 acres on the Salamano site, which we saw in the Johnson presentation, about how you really begin to think about the locality where you are and think differently about how you use what a lot of times we see as detriments rather than assets. Because I think the answers are there. I mean, the environment has solved these issues already, in a sense, and realizes that in certain conditions you can only do certain things. In other places, because of climate difference, a lot of other things happen. And it's telling us where, in a sense, we should mentally think of where we want to locate, rather than a place that maybe has more entertainment, rather than, or in a sense, move from the colder parts of the country to the oceans and so on, but begin to really think about where our migration patterns. And I realize this United States, you can move anywhere you want, but what we're doing is we're packing people on the coast and we're packing them in the south into areas of which are much more disaster prone than anything in the center parts or other parts of the country. And the population growth in California, and you're seeing in Las Vegas as well, has been basically because it's such a great environment that everybody wants to go there. Well, now we've got too many people in California in the sense of causing these problems. In the sense of now, because even when I grew up in Los Angeles, there were water problems in Los Angeles 70 years ago. And it hasn't gone away, it's just gotten worse. So they reach further and further out without really thinking, finding a strategy in a way to begin to deal with where they have growth and non-growth areas.
So you're saying Dick Cheney's not the only one that's in denial? What, you ready to talk?
I'm asking, I'm looking for the cool, I'm looking for the cute.
Everybody
Matthew, yeah. This has been a very interesting journey dealing with a very difficult problem. And it's been interesting the extent to which he's been, resolute about accepting the existing social, psychological, geographical, political situation in Las Vegas, focusing on this single family house and saying, we're all crazy to be doing this, but it's in the system and how can I make it better? And at the same time dealing with it at the giant scale of the water availability in Lake Mead, and then the other end of it, right down to the individual sort of house. And I can tell you personally, reading his document made me pay way more attention to how much water I was using in my house. And that's something else we'll talk about. We'll talk about later this afternoon. So anyway.
By the way, I wanted to compliment you on the shame wall. The minute you come in, you're ashamed.
Shame wall.
Yeah. Hopefully you're not ashamed. Hopefully you're educated and excited about the amount that you're saving.
Yeah, I read it the way Gary did.
Missed it again this week.
It must have something to do with our,
Our age.
well, yeah, and our, I don't know, quasi-religious background or something like that, cultural. our mothers. I think it has a lot to do with our mothers, Gary. That's what it comes down to. So, yeah, please. So the committee was made up of Professor Bogle and Professor Eisenberg.
This whole thing started with water. And that was your main concern. Water, I can say, will be a big sustainable issue, not maybe. You know, I grew up in San Francisco. I've gone through a couple of these multi-year drought situations. I think I'm correct in saying that that investigators have shown that the Mayan civilization died because of a decades-long drought. You know, we can easily see decades-long drought. And I just finished a book on sustainability. One of the things he talks about climate change is that the downdraft of the cycles of air that come down on the Sahara Desert is likely to move north and come down on Northern Europe. Then we're in a world of hurt.
Well, we're seeing the same thing in this country.
Yeah.
It's moving
Yeah.
north.
Yeah, so water is a really big thing, and it's kind of hard to put it into architecture in a way, you know, because it's not busy, it doesn't produce big imagery and stuff, and it's a lot of little things in it, and it's also a fair amount of engineering, you know, but it's going to be a really big issue, and it just hasn't quite registered, especially on the East Coast where we have big rains all the time, you know. Also thought it was interesting that we use as much water as China. Think about this.
Oh, yeah.
The number of people in China versus us.
At this point in time.
Yes.
So I'm glad the committee raised some of the questions. And I have to say, and Matt knows this, that I was, I wouldn't say an ambivalent chair, but I would say challenged the premise of this project from the very beginning. I mean, perhaps it's growing up in New York City, but the notion that people continue to move to Las Vegas and that we then say, okay, well, if you're going to move it, we'll make it as good as possible, and basically we'll extend the amount of time people can live there, and until the crisis really hits, right? And so the question that comes up is, what is the role that architects can play here, right? You get this project, you try to go, I'm going to do the best job, you know, that I can, because there's a need there. So I have to say, I still have to say I challenge that way of thinking. And, you know, I was saying, okay, so what is our role here? Is it, and I think you did, you know, due diligence and figure out the right materials and figure out the ways to think about choosing the right machines, you know, to do it, and you get us down to a little drip there. But I still can't keep thinking about that dripping faucet, right? And how it still adds up. It just takes a little longer for that faucet to add up. And then in contrast, I have to say, I had the opportunity to go to Costa Rica this past year. And in Costa Rica, they did something where after they had this big, this volcano blew up and it destroyed 2 towns, the strategy was then, which was amazing in the 70s, it also to do with a dam, where the continental divide is there, and so the engineers said, well, we have a rainforest here, and if we dig a hole through the mountain, we're going to switch the direction of the water, so it flows from the rainforest into this basin, which was once a lake, create 3 hydroelectric dams, and then at the end of those dams, it's going to give water to an area of our country which is arid and has trouble with irrigation, thus bringing on the economic viability of that community, and ultimately producing 40 to 50% of the power needed for the whole country. And then at the same time staying in a hotel there, and this is like maybe those little details you think about, in the cloud forest where you come out, everything's wet, and you have a little refrigerator in your hotel, in the room, and then the heating coil for that refrigerator is connected to the closet, so that when you put your wet clothes in that closet, they're dry. Right? Because there's the thinking about how those things are connected. And so, it's not a term to you, but I think we need more of that kind of thinking in this country. And I was also thinking about the challenges. Think of your project, Tim, right? We have towns like Hagerstown or Johnstown where we're struggling with not enough people coming in, and we have places where people are building where really they shouldn't be. You know, what role do we as architects play? You know, and maybe Some cases we do our best job at designing to make it better, and there's definitely a job for us here. But maybe there's also the job for us in terms of, before the crisis hits, being the leaders, being the policymakers, making the arguments, somehow to shift our culture so we think more towards the decisions, the ways that Costa Rica's doing things than the way we are. So I want to just thank you for bringing this conversation to the fore. Like Steve, I too, like, turned off my dripping faucet. You know, there's no cold water in my bathroom right now. But I think it raises the question of how we act as educators and as architects, both in the little picture and the larger one. So thank you for bringing that conversation into